Okay, college algebra students, today we will look at part 3 where we solve an absolute value inequality. So we're going to look at, the first thing we're going to look at is the absolute value less than situation. Okay, so let's think through this problem a little bit. Let's see if we can reason out the solution to the absolute value of x less than or equal to 3 just by looking at numbers on the number line. Okay, so we're just going to kind of think about some numbers at work. Well, obviously, absolute value of 2 is equal to 2, so that's less than or equal to 3. That's pretty obvious. And then 1 would work, and 0 would work. Let's see what happens when we get into negative numbers. So if we do the absolute value of -1, that's 1, and that's still less than 3. Let's keep moving on. Let's go to -2. Okay, when we get to the absolute value of -2, that's 2, and that still is right. Let's go to -3. Okay, so if we do the absolute value of -3, that's 3, and then 3 is equal to 3, so that's a solution. Now, if you move on to -4, the absolute value of -4 is 4, then it quits working, doesn't it? Okay, so that's kind of what's going to happen. And one other thing here, another number that would work would be 3. So if I did absolute value of 3, that certainly works because 3 is equal to 3. But notice once you get bigger than 3, that quits working. Okay, so you kind of fall apart once you get bigger than 3 and smaller than -3. So it looks like what would happen on this problem, on a number line, it looks like -3 to 3 is where all the solutions would fall. So on a number line, we would have a bracket to include the 3. Notice that when we included 3 and -3, it worked because 3 is equal to 3. Okay, so then you would shade in the middle like that, and that would be how your number line graph goes. Okay, in interval notation, again, it's beginning, comma, end. So it starts at -3, it includes -3, ends in 3, and includes -3. So just thinking about the problem, it appears that the solution is going to fall between -3 and 3, including 3 and 3. Okay, so in general, the solution to an absolute value of x less than some number a is going to fall between those two numbers, and in interval notation would look like that. So the solution falls between the opposite a and a itself. Okay, all right. So that's how this would go. This is just kind of the summary here. If it's absolute value x less than a, then the solution in interval notation would be like that. If it's absolute value less than or equal to a, then you're going to have brackets and you're going to include those endpoints like that. So that's the generality of what we discover when we look at that basic situation. Okay, so what we'll do now is we'll begin to solve some of these things. So if you solve an absolute value less than problem, this is a less than problem, you always isolate the absolute value. So the absolute value has to be all by itself, nothing in front, nothing outside of it, and then less than or equal to some number. That's your first goal. Okay, then what you do is you put the expression inside absolute value between -a and a. Then you isolate the variable x by itself, write the solution, graph if necessary. All right, so we're going to run through some problems like that and kind of take a look at how these go. So first of all, this one, the absolute value is already isolated. You've just got equal to a number. Okay, so this is the simplest case. What you do is you take what's out of absolute value and you put it in the middle of 2 and -2. So it sets up like that, and then the number line graph would be including -2 and 2 and shaded in the middle. So that's how your number line graph goes on that problem. Interval notation just begins at -2, stops at 2 like that. So that's your interval notation solution. And it's pretty easy to understand this, really. It really is. If you just take numbers in between -2 and 2, they all work. The absolute value of 0 is less than 2. That works. The absolute value of 1 is less than or equal to 2. The absolute value of 2 is equal to 2, so that works. And then your negative numbers work also until you get past the 2. Okay, once you get past that and get into 3, any number bigger than 2, including something like 2.1, well, it quits working. Okay, so you're going to find that the solution is going to fall between this number 2 and the opposite of that number, -2. Okay, next problem. Make sure that this is isolated. There's nothing in front of the absolute value. There's nothing outside of it. So when that happens, and you just have a number on this side, then what you do is take what's out of the absolute value, and you set it in between the 6 and the -6. Okay, that's how you always set up less than problems. Now, the goal is going to be to get this variable k isolated in the middle. So what I need to do is I need to get rid of the add 3. So the undoing operation of addition is subtracting. So I do this. Okay, that's going to leave -9 less than 4k, and that's less than 3. Okay, one more operation does it. So now what we have is we need to undo the multiplication of 4 by dividing each part. Notice we're doing this to all 3 parts. Okay, then that accomplishes our goal. It looks like we have -9/4 is less than k is less than 3/4. Okay, and again, like if you look at your calculator and if you do -9 divided by 4, that looks like -2.25. And then 3/4, you may already know that, I would hope you already know that, is 0.75. So the preferred way to write the answer is just leave the reduced fractions. So when we graph this, we're going to exclude the endpoints because there's not an equal to bar. So what we'll do is just go to -2.25, we'll go to 0.75, and then we'll shade in the middle with parentheses. Okay, so that's how your number line graph would look. Your interval notation would be just begin at -9/4, comma, end at 3/4. Okay, so that's the standard of how you solve absolute value less than inequalities. This thing, shows up in calculus when you learn about what's called a limit in a calculus class. Absolute value turns out to be a real important concept to develop that idea. Okay, but it's a thoughtful problem. It allows you to think about how the absolute value changes the solution. It's going to be in the middle of 2 numbers. Okay, let's go to the next page, and then we'll do one more, and then I'll put you to work and let you do some. Okay, first thing we have to do on this is this absolute value is not isolated. We don't want the subtract 3 to be there. So the undoing operation is adding 3 to both sides. That's going to leave us with absolute value of 6n subtract 8 is less than or equal to 9. Okay, once you get that isolated, then you take what's out of absolute value, just kind of drop the symbols, and you put this in the middle of 9 and -9. Okay, and keep in mind that -9 is a smaller number than 9. That's why we have less than symbols here. It wouldn't make any sense if we had -9 greater than or equal to 6x minus 8 greater than or equal to 9. That doesn't make any sense because -9 is not larger than +9. Okay, so now what we do is we isolate. We need to undo the subtraction of 8 by adding 8. Notice we're doing that to all 3 parts. So that will leave -1 less than or equal to 6 times n less than or equal to 17. Okay, so now we need to divide everything by the 6. So we have -1 less than or equal to 6n less than or equal to 17. The undoing operation of multiplication by 6 is dividing by 6. Okay, so that's going to leave -1 6, which is a reduced fraction. That will leave n, and then 17 over 6 is already reduced. Okay, so if you want to look at a calculator to kind of get a sense of where this is, like -1 6, it doesn't really matter. It's really -0.17 approximately. And then if you do 17 divided by 6, you're going to get about 2.8. So you can change that so that you can get a good sense of where the numbers fall on the number line. Okay, this one is a less than or equal to, so you're going to use brackets, which is going to mean you're going to include the endpoints. So we'll go to -1.7. It's just barely to the left of 0. And then the 2.8 is in there. Shade in the middle. That's the way your number line graph's going to look. Interval notation, where does it start? It starts at -1 6. It includes, so we have a bracket. It stops at 17 over 6. And it also includes that endpoint. So that would be the solution. Okay, now just to show something on this too, and I don't care to do this on every problem, but the thing that's going to happen on this, if you pick a number in the middle, like if you pick x equals 1, and you plug it into the original, look what would happen. You would get, basically, 6 times 1 minus 8 minus 3. Let's see if that's less than or equal to 6. This would be 6 minus 8 is -2. This would be 2 minus 3, which is -1, and see, that's true. And it would turn out that every number in between -1, 6, and 76 would work. It's also worth looking at this. Look at this endpoint. So like if I plug in 17 over 6, it's kind of good to see how these endpoints work. Look what happens. Well, that just crosses the 6's out. You'd have absolute value of 17 minus 8 minus 3. That would be 9 minus 3. So this would be 9 minus 3 would be 6. And notice that they're equal to each other. So that endpoint, both of these endpoints, if you plug them in, should work. Okay. And what will happen is if you take a number outside, like if you plugged in 4, 4 wouldn't work. If you plugged in -2, it wouldn't work. You can verify that by plugging the number in. Okay, and that's real important. It's sometimes pretty easy to just plug these endpoints in and work it out in your head. With a little practice, you can learn to tell you're right on these problems. And that's an incredibly important thing in math, is if there's a way to determine that you're right, take advantage of that. All right, so let's go ahead and pause the video here, and I'm going to let you all work these two problems out. And let's see, I think that's it. We'll just go through those problems. As soon as you're done, resume the video, see if you got them right. Okay, so now you can begin to go through and check and see if you work these out correctly. So on number 1, the absolute value is isolated. Okay, so notice I put the 2x minus 6 without absolute value in the middle of -4 and 4. Okay, isolate the x, so I added 6, then I divided by 2, and you get 1 is less than x is less than 5, which means that the values of x are between 1 and 5, but the endpoints are excluded because there's not an equal to bar under the inequality. So your graph would just be shaded between 1 and 5 with parentheses. Interval notation is just 1, 5 with parentheses. Okay, second one, you have to start by isolating. Okay, so add 4. You'll get this, then divide by 2. You do not want to distribute that now. Okay, don't distribute that. It's okay if it's a positive number that can distribute through, but if that's a -2, you're going to mess up the problem if you distribute. So it's a good rule of thumb to just not distribute into absolute value. Okay, so now we'll put this between -5 and 5 and then solve. Okay, so you would have ended up getting -11/3 less than or equal to k less than or equal to -1/3. And on the calculator, it's really -3.6. So my graphical solution looks like this, between -3.6 and -0.3 approximately. And then there's your interval notation. Make sure you got brackets. You are including the endpoints on this particular problem. Okay, so hopefully everybody did well on that. Okay, moving down to the next thing, and you can pause the video right now if you need to get things copied and kind of review what I did there. You move down to example 3. There's a few kind of special cases that pop up on these problems. So on this one, this problem says the absolute value of x is less than -4. Sometimes you just have to think about problems. This says, can you think of any number for x that makes this inequality work? Well, you could try every number you wanted to. Absolute value of 0 certainly does not work. Absolute value of any positive number certainly isn't going to work. How about negative numbers? How about if you tried -4? Well, the absolute value of -4 is 4, and 4 is also not less than -4. So what you're going to find on this is, the absolute value of x is going to give you 0 or a positive number. And it's impossible for 0 to be less than -4. And it's also impossible for a positive number to be less than -4. So the answer to this problem is no solution. Okay, sometimes inequalities and equations do not have solutions. So you can just write it out that way. A lot of times we write a 0 with a slash through it. That's called the empty set. So the solution is the empty set. You can just say no solution. So the reason why is because an absolute value will never give you a negative number that would be smaller than -4. It's impossible. Okay. So you have to kind of be careful when you do these. You wouldn't want to work these out. And another way to look at this problem is, the absolute value is already isolated. So what I have been saying to do is set this between the number and the opposite of the number. Now look at this. This is nonsense. 4 less than -4, nonsense, total nonsense. So it doesn't even make any sense to set it up. Okay, the next problem, well, the first thing you have to do is you got to isolate. So you'd subtract 2, and you would end up getting absolute value of 3x minus 1 is less than -12. Same idea. There is no way in the world that an absolute value of anything can ever be less than any negative number. So this one, again, is no solution. You can just abbreviate that like that if you want, or you could do, again, the empty set symbol. Okay, so this is just sort of a special case. If you see an absolute value isolated of anything, that can never be less than a negative number. That would automatically be no solution if you spot that. Okay, so that's kind of a special case. Okay, now what we're going to do is look at absolute value greater than problems. So we're going to kind of look at this in a little bit different light. The first thing we're going to do is look at, let's just determine what the solutions to this are. Now, absolute value x greater than or equal to 3, it should have the opposite solution to absolute value of x is less than 3. That's one way to think of that. And the solution to absolute value of x less than 3 is numbers between -3 and 3. So what is the opposite of numbers between -3 and 3? The opposite would be numbers bigger than 3 and equal to, or numbers smaller than negative 3. Okay, so let's kind of reason this out. Let's just plug in some numbers to see what works. So it's pretty obvious that absolute value of 3 is equal to 3, so that definitely works. And let me kind of put this over at the side here. Okay, so it looks like 3 definitely works. Absolute value of 4 is greater than or equal to 3. Yeah, that definitely works. And so forth. I mean, if you change this to absolute value of 5, it's pretty obvious that all of these numbers out here are going to continue to work forever. Okay, now you could start trying numbers less than 3. Like if you try 2, that definitely doesn't work. 1 doesn't work. 0 doesn't work. Go on to some negative numbers. Absolute value of negative 2 is equal to 2, and that's still not greater than 3, so that doesn't work. Okay, go to negative 3. Absolute value of negative 3 is 3, and it is true that 3 is greater than or equal to 3. So it looks like negative 3 works. And let's try some other numbers like negative 4. Well, that's 4, and 4 is greater than or equal to 3. So what you're going to find is the absolute value of negative 3, negative 4, and negative 5 are going to change to positive numbers, so they're going to be bigger than 3. Okay, so your solution looks like it's numbers bigger than 3 and equal to 3, or its solutions of its numbers less than or equal to negative 3. Okay, so if you were to graph the solution on here, on your number line, you just need to put these 3 numbers, and the solution would go like this. It would be numbers larger than or equal to 3, including, and numbers less than or equal to negative 3, including negative 3. If you write this in set builder notation, typically you write set of x such that x is less than or equal to negative 3, or x is greater than or equal to positive 3. So that's how you write what we call a set builder solution for that inequality. The interval notation solution, you have to write it this way. There's 2 solutions, really. So one of the solutions is below negative 3, including negative 3. So your interval is negative infinity to negative 3. Your other solution is 3 and bigger, so that would be 3 to infinity. And what you do is you put this symbol U stands for union. It just means you are uniting 2 different solutions. So that would be written like that. So that's the basic idea of how you do an absolute value greater than problem. Okay, so it's real helpful if you understand why these solutions work the way they do. All right, so here's kind of a summary right here. So if you're solving the absolute value of x greater than a, then on a number line, it's going to go like this. You're going to have a and negative a, and your solutions are going to be bigger than a and smaller than negative a, like that. Okay, the interval notation solution will look like that. Negative infinity to negative a, and then union a to infinity. Okay, the second one, slightly different. If you're doing absolute value of x greater than or equal to a, then it goes like this. Okay, what you'll have is numbers larger than a and numbers smaller than negative a. And in this case, your interval notation solution looks like that. Okay, so you have to kind of make sure that you understand that this one, greater than, is going to exclude the endpoints. So you use parentheses like we've talked about. Greater than or equal to is going to include those endpoints, which is why you use a bracket. Okay, so that's a summary of how you do an absolute value greater than problem. Okay, so here's kind of the idea at the bottom of the page. This is generally what you do. Step 1 is you have to isolate the absolute value. You don't want anything in front of it or anything outside of it. So we're going to start by undoing the adding 8 by subtracting 8. That's going to leave us with absolute value of 2x subtract 4 greater than or equal to 12. Okay, now what you do is you have to set up two things. You set up two inequalities. You have the one going to the right, so you're going to solve the equation 2x minus 4 greater than 12. Okay, then you have the solution going to the left, so you have to solve 2x minus 4 less than. The reason we're doing less than is because we're going to the left of the opposite of that number. So when you set up your inequality, you set up two things. You do the greater than part, greater than the number, or smaller than the opposite of the number. And then you can solve these two inequalities. So to finish this, real simple, you would add 4 to both sides here. So that would give 2 times x is greater than 16. Okay, then you could divide both sides by 2. So one of your solutions is x is greater than 8. Same thing over here, undo the subtraction of 4 by adding 4. Okay, that's going to leave 2x less than negative 8. Undo the multiplication of 2 by dividing. That's going to leave x is less than negative 4. Okay, so that's your solution to your problem right there. Okay, and a good thing to do on these problems is, let's just do this. Just plug in the negative 4 and see what happens. Just plug it in. Okay, you would have 2 times negative 4 minus 4 plus 8, and you just need to see if that turns out to be 20. This should be 20. That's an endpoint. So that would be absolute value of negative 12 plus 8. This would be 12 plus 8. So see, that's equal to 20. Now, this is a false statement. That's why you exclude that endpoint when you graph that. Okay, and you could do the same thing with the 8. If you plug the 8 in, you would have absolute value 2 times 8 minus 4 plus 8. That's going to have to be 20 also. Whoops. Okay, so let me just kind of prove to you that that's going to be 20. This is going to be 16 minus 4 is going to be 12. And then 12 plus 8 is going to be 20. So it's equal to 20. That's how you can tell your endpoints are correct. Real simple. Okay, all right, so let's see. We'll go to the next page and I'll do a few more problems, kind of put this together, and then we'll wrap up the section, have you do a few problems. Okay, so these are all greater than problems. You have an absolute value greater than. So it's helpful to know that the graphical solutions to these generally is going to be pointing in opposite directions with some little gap in the middle in general. So we set this one up like this. This one's already isolated. We just say x is greater than 3 or x is less than negative 3. Okay, that's how that one goes. So this one, your graphical solution would be parentheses, shade to the right of 3 because x is larger or greater than 3, and then parentheses, shade to the left of negative 3, like that. So that's your graphical solution. Okay, interval notation would be negative infinity to negative 3 would be this solution, and then union 3 to infinity would be that solution. Okay, so that's how you put that together. That's the real basic kind of example right there. Okay, the next one, first thing you got to do, well, you got to isolate. Okay, so you do not want that 6 there. You do not set these problems up yet. Students have a tendency on this to do this. X minus 5 plus 6 greater than or equal to 11. X minus 5 plus 6 less than or equal to negative 11. If you do that, you'll get one answer right and one wrong. You have to isolate first. Do not start the problem that way. So you're going to subtract 6. That's going to leave absolute value x minus 5 greater than or equal to 5. Okay, now you're ready to set it up. Now you can set it up. So you have a solution going to the right. So you solve x minus 5 greater than or equal to 5. You have a solution going to the left. And be careful here, left is less than, and then don't use 5, use -5. So that's how you set up that problem to get your solution. Okay, now it's pretty easy to solve these two inequalities. You're going to end up getting x is greater than or equal to 5 for one answer. And then over here, add 5 to both sides, you're going to get x is less than or equal to 0. Okay, so those are your two solutions. If you go to your number line, what you do is put a bracket on 5 and then shade to the right. That's x greater than or equal to 5. Put a bracket on 0 and then shade to the left. So that's how your number line solution works out on that problem. For interval notation, it would go like this. You would say -infinity to -5, bracket, union, bracket, 5 to infinity. Okay, so the structure of these answers, you're going to have one solution go to the left, one solution go to the right. Okay, let's see what happens on this next one. So the next one, well, the first thing you'd have to do is isolate. So you'd have to add 6 to both sides. So that's going to leave you with absolute value of 4k plus 4 is greater than 3. Okay, so what happens here then is you're going to set up two solutions. The solution going to the right is going to be 4k plus 4 greater than 3. The solution going to the left, you're going to solve 4k plus 4 less than -3. Okay, then it's just kind of a matter of solving a basic inequality. Over here, subtract 4. You're going to get, from here, you're going to end up getting 4k is less than -7. Divide by 4, you're going to get, one of your solutions is k is less than -7/4. Same thing over here, subtract 4, you're going to get 4k greater than -1. Divide by 4, you're going to get k greater than -1/4. Okay, and then as far as your graph goes, just shade to the right of -1/4. And -7/4 is -1.75. So shade like that. That would be how your number line graph goes. And then your solution would go like this. So you would say -infinity to -7/4, union -1/4, comma, infinity. Okay, so that's how these problems go. See, they're all done the same way. It's just kind of a matter of setting those things up correctly. Okay, so pause the video here if you need to get any of that written down, or you need to kind of go through and think about that a little bit. Otherwise, let's go down to the very bottom, and I'll let you try these problems. Pause the video as soon as you're done. Resume the video and see if you got them right. Okay, so go ahead and check and see if you got this. So number 1, your solutions are x greater than or equal to 5, which gives the graph 5 with a bracket to infinity, and then x less than or equal to 1. Okay, so that's how you would write that in interval notation. Again, the setup is you have to set two things up. You have to set up the inequality, this inequality, you have to set this up, and you got to set that up. Greater than or equal to 4, the other one's less than or equal to -4. Okay, the second one, you had to isolate. You had to get down to this point. Add 4 to both sides, divide by 2. Do not distribute the 2 through there. And once you get to that point, again, these are the two inequalities that you're going to set up. Okay, and then run through the solving. You would end up getting k greater than -1/3, and you would end up getting k is less than -1/3, like that. Okay, so you can see how I did the graph and how the interval notation went on that problem. Okay, so the last one is kind of a weird problem. This one said absolute value of x is greater than or equal to -4. There's a tendency for students to want to just go, okay, I just set it up like the teacher told me to. And you know, there's nothing really wrong with doing that. I mean, you'd end up getting x is greater than or equal to -4 and x is less than the opposite, but that's the whole number line. I mean, what happens is if you are less than 4, then you're going to be like that. If you're greater than or equal to -4, you're going to be like that. So you are really coloring the entire number line. So any number, when you take the absolute value of any number, the result is always going to be larger than a negative number. So that's why it's all real number solutions. Okay, all right, so that will wrap up this video. Hopefully this helps you to get a good handle on this topic.